One night while I was getting ready to go to bed, I had a realization. If all information can be conveyed through a constructed medium called language, and if language itself is merely permutations of a limited character set, then why not convey information in other patterns? Say in that of stars, for example. I could have stopped there and had a good night's rest, but no. I didn't want some way to store just some information. I wanted to store every possible information in the stars. The idea I came up with to store any information in the stars is to give each star its own byte information, so patterns of stars could create chunks of information. In this project I mainly wanted to experiment with text, so I'll assign a character to each star. Now the question becomes, how many characters are we going to store and how are we going to store them? After all, I want to store every possible text out there, right? Well, not really. Although it is true that every string ever and ever will be are just permutations of a limited character set, it doesn't necessarily mean that the length of those strings will also be limited. I could use just 26 characters to create a unique sentence that is infinitely long, which would also imply it would take an infinitely long time to compute. So I decided to take a different approach, one that I was already familiar with. You see, a few months ago I worked on a project called the Library of Babel, which was based on a book by Jorge Luis Borges, in which he tells us a story about an infinitely large library containing every single permutation of every single character set out there. Therefore, it must contain a lot of nonsensical gibberish, but also within it every written information ever and ever will be. In that project, I captured the essence of the unlimited by simply using a 3200 character limit per page. Though it's not exactly storing every possible permutation of the given character set, it is storing every possible 3200 character page ever. Now, if you're unfazed by that statement, here's the number of possibilities that system covered. Yup, that is a lot of possibilities. In fact, the number of stars contained in all of Milky Way galaxy is less than a fraction of this number. And to be quite frank, it's something that I still can't comprehend till this day. If you want to know how I did it, go watch my video on the Library of Babel. So for this project I decided to store permutations of only 3200 characters. And in order to cover the entire range of possibilities, I came up with a star cluster system. Each star cluster is unique and made up of 3200 uniquely positioned stars. I also gave each star cluster its own address in order to generate the cluster itself, but also to help search for it in the immense sea of possibilities. This helps us establish the notion that the information a user may search already exists within our program. One problem I had to solve in order for this to work is to make a system that somehow creates unique vector positions based on a star's cluster address. I first thought I could somehow extract the vector 3 positions from the address itself, but quickly realized it would be impossible given the fact that the address is just a concatenation of many 5 bits. A little context on the address I'm talking about here. This hexadecimal string is just a product of very simply encrypting the input text itself. In other words, at any given time we either take the user input or a random permutation of length 3200 and perform some simple bitwise operations that result in this hexadecimal string. This does two things. One, since the input text is the address, it is guaranteed to be unique. Two, it ensures that we already have every single permutation in our system without actually having to store them. Now back to the problem of generating unique positions. This time, instead of manipulating the address itself, I used a random number generator. Why a random number generator, you ask? Well, random number generators are not actually random. They are pseudo-random in nature, which means they take an input called a seed and generate a sequence of numbers that is unique to that seed, like you see in Minecraft. So if I pass the address as a seed into the random class, I should get a unique star cluster, right? Wrong. For one, changes made to a single character doesn't make any difference, and the star positions are determined exclusively by some bytes and not others. This is because a random number generator takes in only 10 digits of type integer as a seed, but the hex address, when converted into its number equivalent, becomes a very big number. In fact, I had to use C#'s big integer class to store it. This means our seed can only be any 10 digits of this big number, and thus there's a high probability for duplicates. The only way to solve this problem is to somehow reduce the size of this big integer, so it can be accepted as a seed, but at the same time remaining unique. I tried various approaches like compression, hashing, creating my own RNG, and even more bitwise operations, but all failed. I was stuck on this for 3 days and slowly began to lose interest. But on the 4th day, I thought I'd give it one last shot and asked online for help. And I got the answer. The almighty modulus operator. Thanks to this person for helping me out. As far as I can tell from the internet, the results of the modulus operator are uniquely determined by its dividend and divisor. And this is exactly what I needed. So I took the modulo of the big integer and the max value of int and passed the resulting number into the random class. And it worked. Now changes made to any character in our address will result in a completely different star cluster. This means we have already stored every possible 3200 character text in the form of star clusters. I now had a system that stored every possible 3200 character string in the form of star clusters. Even though my initial goal of storing information in the stars was complete, it was, for a lack of better terms, still too abstract. You see, when I conceptualized this project, I wanted to do one thing better than my previous project. I loved the profoundness of the Library of Babel. It transcended time itself in a way, and also stored an immense number of possibilities in less than 200 megabytes. But it failed at one thing: impressing people. When I first showed it to my friends and family, they must have thought I had just made a random text generator. They didn't realize that anything they could think of was already out there. I felt like I hadn't properly captured the core principles Jorge Luis Borges was trying to convey. That something can only be appreciated against the contrast of nothing. So I came up with an idea to make this whole experience a little more appealing, and that was to encode messages in the form of constellations. After all, it's what we have been doing since we looked up and peered into the night sky. As for how the system will work, I wanted to create strings of information by connecting stars together. Think of it as taking a random page in a textbook and circling the characters you like and then joining them together to create a new text. In our scenario, this page will be our star cluster. So I got to work. I first needed to create lines between each star. This can be easily done with the help of the line renderer component in Unity. Next, I needed some way to keep track of the mouse clicks on each star. This can be done by adding a collision shape to our star prefab. In some regards, this does affect performance, so instead of spawning a lot of 3D spheres, I instead used a 2D sprite and gave it a neat billboarding effect. Since we have the collision shape, we can use the on mouse down function to tell the star to add its position to the line renderer's position array when the user clicks on it. All that's left to do now is to go to our update method and render the line from the position array. And now you can draw constellations in the sky. As for creating the string itself, it's pretty simple. Let's go back to the on mouse down function and pass in an additional instruction to add the star's byte information into a separate array. Now if we join all the characters in the update method, we get the constellations corresponding text. Next, I implemented a fun telescope system. This allows the user to zoom into and pinpoint any given star. I made this with the help of Unity's physical camera mode. By toggling this option, you get access to the focal length parameter. Then I tweaked its value using the scroll wheel as input during runtime. And voila, a neat little zooming mechanism. Lastly, I wanted to implement a constellation search feature. This is pretty simple because whatever a constellation may be, it will always be limited to the combination of characters available in a star cluster. So I pretty much just made a system that creates a star cluster from a given constellation. I did this by taking the constellation string, padding it with spaces if needed, and then creating a hex address from its shuffled state. This hex address will then generate a star cluster. Now to draw the constellation itself, I went through each star in the cluster checking for matching character info. If it matched, then I added it to the line renderer's position array. So now any constellation you may search is already out there. But you might have noticed a problem. A few problems in fact. One, our search only returns one result. This result is the exact match of the text input. But there may be million other star clusters containing our same constellation. Kinda like how Google shows various results containing our search keyword. This is relatively easy to fix, but I haven't really gotten to working on it yet. Another issue that rises is one that of aesthetics. For 90% of the searches, we get results that barely resemble constellations. And also if a user wanted to encode a message into a constellation which uses every star in a cluster, the night sky becomes a mess like this. This is a problem that isn't as straightforward to fix and is relatively harder. The reason being the way the algorithm is structured itself. First we spawn the stars with the characters, and then and only then do we make constellations. This obviously means we have zero control over the positions a constellation might take to create itself. At the time of recording, I might have a solution in the back of my head, but this is all the progress I've made thus far. So for now, if you enjoyed the content, please leave a like and consider supporting me by subscribing. With that said, I will see you in the next video.